ACIS is the Applied Climate Information System. It has been developed by the Regional Climate Center program over the last several years. The purpose of this webinar is to give users an overview of the ACIS system. ACIS integrates data from any number of observation networks. It eliminates the need for users to obtain data sets from different places. All data, regardless of source, can be accessed and analyzed through ACIS. At any point in time, users get the highest quality data that are available for a particular site. For NOAA data, there is a hierarchy of data sources, with data of the highest quality being preferentially returned. If available, the summary of the day DSI 3210 or DSI 3200 data are returned to users first. Otherwise, summary of the day CDMP, DSI 3205, and DSI 3206 are returned. These data are typically from the earliest parts of a station's record. More recent data come from the GHCN Daily. The holdings in ACIS include observations from the CoCoRaHS network, Canada, Mexico, the Pacific Islands, and also the Caribbean. The RCCs also ingest data in real time. These data are made available to users only when GHCN daily observations are not available. From the NOAA port, ACIS daily summary messages are ingested and made available in ACIS, as well as NOAA port daily CF6 messages. The CF6 messages have the highest priority of all real-time data. In fact, they even take precedence over the GHCN. Eventually, these will become the GHCN's preferred source of ACIS data. The RCCs also maintain a number of Chef encoders. Chef-encoded co-op data is added to ACIS numerous times during the day to assure that the most recent data are available to users. Some RCCs also key data locally. These may be co-op stations that do not use WeatherCoder or other sources of information. They are added to ACIS when available. Likewise, National Weather Service offices have also keyed data locally. These data sets, which typically are in a station's early period of record, are available through ACIS. Non-NOAA data is also included. These data sets include ThreatX. These are long-term station extremes that have been developed by the RCCs for use by both the National Weather Service and the media. We also plan to add other networks as needed by users. These can be a variety of state, local, or regional networks. The newest data available in ACIS are gridded data. These include station data that have been gridded to a 5-kilometer grid. These are similar to the data used to produce the RCC ACIS maps that are familiar to many users. 5-kilometer gridded drought indices will also be available based on the station data. Most recently, downscaled GCM projections are also included in ACIS. These are a part of the national assessment and include the global and regional climate model projections available from NARCAP. Metadata are also included as a part of ACIS. Metadata are updated frequently to coincide with NCDC and are synchronized among the RCCs. One important role of ACIS metadata is that it allows the mapping of stations between different data sources. For instance, the same data can be obtained whether a user specifies a station's wayband or co-op ID. Likewise, at a long-term site, a continuous string of data is returned, which may span portions of the DSI 3206, 3200, and GHCN datasets. In addition, more recent data may have come from Chef-encoded real-time observation. Available station metadata include station identifiers, station name, geographic information such as coordinates, elevation, and time zone, the county and state associated with the station, as well as the valid date range for data. Metadata are also included that describe the observations. These include data quality flags, the time of observation for each data element. Eventually, information about the dataset from which individual observations are obtained will be included. The metadata also allow ACIS to query stations based on their location. A user may request data for all stations within a county warning area, state, or river basin, or they may specify a rectangular area over which to identify available data. ACIS also incorporates quality control, especially for its real-time data. For archived data sources, NCDC quality control takes precedent. However, for data received in real time, automated internal consistency checks are performed. These checks flag data values, which are subsequently validated by RCC staff. There are multiple ACIS servers and databases at RCCs across the country. All are synchronized to assure users receive exactly the same climate data, whether they access the server in the High Plains or the Northeast. A broker relays requests to available servers. This limits downtime and distributes user volume across multiple servers, particularly during times of high usage. Some datasets, such as the AWDN, are housed at a single site. Requests for such data are automatically routed to the proper server. Information is at the core of ACIS. The system's strength is its ability to translate data into information. ACIS should be thought of as more than just a means of accessing climate data. Through years of experience, the RCCs have learned that most climate information requests rely on a set of basic data summarization methods. These methods are a key part of ACIS. ACIS users can take advantage of these summaries to quickly and efficiently handle a number of climate information requests. The ACIS summary routines have been designed by RCC climatologists to provide consistency in the climate data products generated by the climate centers and to align with standard national and international summarization practices. There are 6 main summarization methods included in ACIS. Users can average a climate variable such as maximum temperature over standard periods like months or years, or provide their own averaging interval. Similarly, variables such as precipitation or growing degree days can be summed over different time intervals. The extremes routine allows users to identify the highest or lowest value within a time interval that they specify. Data intervals can also be queried to return the number of days on which a variable exceeds or falls below a threshold. Days over 90 degrees F is a common request. ACIS can also answer questions such as when was the last time we had 12 inches of snow, or when was the last frost in 1962. How long has it been since it last rained? The consecutive days routine provides a means for tracking the length of dry periods, heat waves, or cold spells. Users can also specify the interval over which to temporally summarize the data. This can be standard months or years, the season or year to date, or some other user-selected period. Spatial summarization is also possible with gridded data. A spatial average might show the average temperature for a month in a particular county. Spatial extremes might indicate the highest precipitation total in a river basin, or the percent of the basin that received rainfall in excess of 2 inches might be computed. A number of commonly used climate variables are derived rather than directly measured. ACIS provides direct access to parameters such as growing, heating, and cooling degree days and daily average temperature. So, how might you as a user access ACIS? There are 3 main methods of ACIS access. Currently, most users are familiar with the web interface. Internal National Weather Service users know ACIS as XMACIS, the name given to the website that allows them access to a number of ACIS products developed specifically for their use. The general public might know ACIS by the Now Data interface that is available on all National Weather Service websites. Increasingly, RCC and external users are accessing ACIS via web services. This interface substantially lowers the hurdle for use of ACIS by climate service providers. Subsequent webinars will focus exclusively on this access method. ACIS is another example of an ACIS web interface. Web services provide the behind-the-scenes connection to ACIS, while menus allow users to set the web service options in their browsers. Web services provide a more direct method for access to ACIS. It allows users to conduct multiple requests, say for data from more than one station simultaneously, eliminating the need to click through web page after web page. This interface also allows climate service providers outside the RCCs to develop their own tools and products that rely on ACIS data and summarization tools. This greatly expands the scope and efficiency by which the community can provide climate services. It also relieves providers of the chore of each maintaining their own separate databases. Besides a savings in time, this avoids the embarrassment of the same product showing different data obtained from different members of the climate service community. To facilitate the use of ACIS web services, a developers workshop is being sponsored by the Northeast Regional Climate Center. The workshop is open to all climate service providers, including state climatologists, climate science centers, RISAs, and federal agencies. We also hope to attract interest from the private sector. The workshop will be held August 7th through 9th at Cornell University in Ithaca, New York. The sessions will be based heavily on hands-on ACIS development, guided by RCC staff. Subsequent web tutorials will provide the necessary prerequisites to limit the time spent lecturing in the classroom. We plan to release 5 additional video webinars in June and July. Workshop space is limited, so please register using the electronic form on the data.rcc-acis website.